So let's see the example how DFS works from a graph. All right. Now in the DFS we'll use the stack operation, but for each of the node we are going to actually keep track of two important information. Okay, so for each of the node we are going to keep track of two information for each node. One is the start time and one is the finish time. Okay, so start time means when the node was first visited, and finish time means when the node when finish time means when actually there is the dead end and we'll start doing the backtracking. Then that means the node's job is done, the node is finished its exploration, and we'll pop the node from the stack and we'll keep track of its finishing time. Okay, so let's see how it works. Say from this graph, so we'll start initializing. This is our root node 1, so we'll uh, push the node 1 root node in stack. Okay, all right. So just I want to remind you, stack support the operation LIFO. Okay, so last in first out. So which the node that was pushed in the stack last, it will be popped from the stack first. Okay, last in first out. So we'll push the stack 1 first. Okay, now 1 has how many neighbor nodes? 1 has actually couple of neighbor nodes, so 7 2 3. Okay, now in the stack actually whichever neighbor node we are going to visit first, depends on that our DFS tree can look different. Okay, so let's see, from 1 we are visiting from 1 we are visiting node 2. Okay, so node 1 has 7 2 and 3 neighbor node. Let's see, we're visiting node 2. Okay, so what means stack 1 and we are going to push node 2. Okay, so let's see, this is our stack. Okay, so we'll push node 2. Okay, now when we are actually visiting the node, we are going to keep track the start time. Okay, so the node 1 is we are visited first, so we'll enter the start time 1. So after 1 we are visiting the node 2 and we pushed the node 2 here, so its start time will be 2. Okay, all right, and this is the edge we used to traverse the graph. Okay, it will be actually part of the tree edge. Okay, so we are actually we are actually doing bold this edge, so this will be part of the tree edge. Now from 2 we can actually visit 7 or 4, either any one of them. Okay, so let's visit the node 4. Okay, so 4 we'll push the node 4 and the start time will be 3 or 4. Okay, all right, you can see we are actually going deeper. Okay, we'll backtrack when we cannot go further deep. So from 1 to 2, 2 to 4. Now from 4 we can go either 3, 5 or 6. Okay, now let's see, from 4 we are going to 3. Okay, so its start time will be 4. All right, and we are actually keeping track of the edges that we are using to traverse the graph. Okay, so they will construct the DFS tree and they will be known as the tree edge. Okay, so after 1 2 3 and 4 1 2 4 and 3, so we'll push the node 3 here. Okay, so from 3 we can go either 2 or 5. From 3 we can go in 1 4 and 5. Now 1 and 4 is already visited, so we are not going to visit them twice. Okay, so from 3 we can go only to node 5. Okay, so we are going to node 5, so which means we are going to add 5 in the stack. All right, and 5 the start time of 5 will be 4 plus 1 5. Okay, let's see how it looks. and our stack has 1 2 1 to 4 3 and 5. Okay, and its start time is 5, and we highlighted this edge because we use this edge to we are using this edge to traverse the graph. Okay, so from 5 we will go further deep. 5 has 3 4 and 6 neighbor node, but 3 and 4 is already visited, so we are going to go to 6. Okay, so we'll add 6 in our stack. All right, and you can see in here, from here to here, and its finish time will be 6. 5 plus 1 6. Okay, all right. Now from 6 has two neighbor node 4 and 5, and all of them are visited. Okay, so from 6, from that point we cannot go actually further any deep. Let me go over again how actually we are visiting from node 1 1 to 2, 2 to 4 4 to 3 3 to 5 5 to 6. We are going deeper and deeper. Now from 6 we cannot go actually any more deeper. Okay, now we are going to start backtracking. Okay, so we are going to start backtracking. So from 6 we are going to go back to 5, not 5. Now when we are going to do the backtracking, first of all we have to pop the node. Okay, so we'll pop the node, and we are going to now keep track of the finish time. So for each of the node we are going to keep two information: the visit start time. Okay, so start time or visiting time, and finish time. So when we finished visiting the node. Okay, so from 6 we don't have any more node to explore. We cannot go any more deeper. When we are going to start our backtracking, that means we finished the node, visiting the node 6. Okay, so the finish time, we are going to keep track of the finish time. So finish time of 6 will be now 1. Okay, so from 6 we'll go to the node 5. Okay, and we'll look that whether 5 has any other child node that we can explore. Okay, now from 6 we are now at node 5, but 5 doesn't have any other child node that we can explore. All other child node of 5 already visited. Okay, all right, so there is no other node. So from 5 we are going to also do the backtrack. Okay, so from 5 we'll actually pop the node 5, and after that we have the node 3. That means we visited 5 from 3. Okay, so we'll backtrack to node 3. All right, okay, so from 3 also we don't have any other child node to visit. Okay, so that means we'll pop the node 3. Okay, so from 3 we'll go to node 4. So from 4 we are going to look whether we have any other unseen child node, unvisited child node. There is no other node. From node we are going to go to node 2. Okay, all right, we'll pop the node 4 and we'll go to node 2, and in that time we are going to also store the information of finish time. So from 6 to 5 the finish time will be 2. So from 5 to 3 finish time will be 3. Okay, so after from 3 to 4 the finish time will be 4. All right, now from 4 to 2, now when we are at 2, okay, we have one unexplored or unvisited child node. Okay, so we'll find that we have one unvisited child node, which is 7. All right, now at this point we are going to actually add 7 in the stack. So at this point our stack will look like 1 2 and 7. Okay, 1 2 and 7, and we'll actually use that as our tree edge. Okay, all right, 2 to 7, and from 7 we'll find there is no other node. We cannot go any more deeper from 7. Okay, all right, so let's see how it looks. All right, So 7 from 7 the finish time will be the last sorry, the start time will be the last start time, 6 plus 1 7. Okay, now from 7 at this point our stack will look like this. Okay, and this is our tree edge from 2 to 7, and our stack looks like this. Now from 7 also we cannot go any deeper, so from 7 we will also start doing the backtracking, and we will, this is our stack now, we'll pop the node 7. All right, and we'll start doing the backtracking, and then we are going to actually, so our last finish time was 4, so now for 7 when we are popping the node we will also store the information of finish time, which will be 5. Okay, our last finish time was 4 and now the finish time will be 5. Okay, then we will go to node 2. Okay, now from 2, now from 7 to 2, now we are going to look whether is there any unexplored node, but there is no unexplored node, so we are going to actually pop the node 7, sorry, pop the node 2. Okay, we'll go to node 1, and before that we'll use the information, we'll keep track of the information of finish time of node 2, and which will be 5 plus 1, last finish time 5, it will be 6. Okay, so from 2 and we'll keep backtrack to node 1. 1 doesn't have any more other child node that we can explore. Okay, we popped that. So now, okay, now we are going to pop node 1, and it will keep it will edit its finish time, 6 plus 1 7. Okay, and our stack is empty, so it will start finishing the traversal of the graph. Okay, so now as we used stack, you can see that the node actually we visited first, the node 1 was actually finished last at the time 7. Okay, and these are our tree edge we use to explore all the node. So from 1 to 2, 2 to 4, 4 to 3, we went to 3 to 5, 5 to 6. Okay, then we start doing the backtracking, and 2 to 7. All right, so this will form a DFS tree, and these are the our tree edge, and all other edges that was not used to traverse the graph. Okay, or you can say all other edges that is not part of the tree edge, they are known as back edge. Okay, all right, so this is our example 2. So why don't we use like few more minutes, say 5 to 7 minutes, and run the DFS algorithm starting from starting node of 1. Okay, starting node of 1, and draw the DFS tree and find the tree edge. Okay, find the tree edge, and all other node that is not going to be part of the tree edge will be the back edge. Okay, so find the DFS tree and you will find the tree edge. Okay, and keep track of the information of start time and finish time. Okay, all right, so in our next video, so you use 5 to 10 minutes, and in our next video we are going to discuss about the solution of this DFS on this graph. Okay, see you in our next example, see you in our next video.